Hi guys, this is Dr. Manjuna Chennapagod from Anveshana Academy, Bangalore, India. Dear students, in the previous class we discussed about what is diesel cycle, what are the important process that diesel cycle has that we have discussed in detail. Okay, so in today's class I am going to discuss about again a diesel cycle only. In this class what I am going to do, I am going to derive an equation for efficiency of a diesel cycle. Okay, diesel cycle. Okay, dear students, in the previous class we studied in detail about what is compression process, what is heat addition process, what is expansion process, and constant volume heat rejection. Because it is very important to derive the equation. Once again I will do repetition in quick. What is isentropic compression? Isentropic compression is a process in which air gets compressed when the piston moved from BDC to TDC. The pressure and volume, temperature, they are going to change from point 1 to point 2. That is nothing but what? Isentropic compression, but there is no any heat transfer at all. That we can call as a adiabatic compression. Second process is heat addition. Heat addition, what we are doing now? Second process. This is what? First process. This is what? Heat. Second process. First process and second process. In the second process, what we are doing? At constant pressure, we are going to add the heat. How we are going to add the heat? Just we are going to inject small quantity of diesel into the cylinder at constant pressure. That means what? P2 equal to P3. That is nothing but what? Constant heat addition at constant pressure. Okay, so therefore only we are calling it as a constant pressure process. Okay, fine. Now this is what? Second process. Third process is what? Isentropic expansion. In isentropic expansion, what happens? Because of heat addition, the whatever the hot gas and fuel, whatever it is there, right, it's burnt and it becomes hot gas. That hot gas, what it will do? It is going to expand the pistons adiabatically. That means what? The piston will start to move from TDC to BDC, hence the expansion will take place. But in that expansion process there is no heat transfer at all, hence we can call it as a adiabatic expansion process. Whereas again the pressure, temperature, volume, they are going to vary from 3 to 4, that we can see in the PV diagram. That also I discussed. Okay, the last process is, this is what? Third process. Then last process is what? Constant volume heat rejection. Just what we will do, we are going to open the exhaust valve. Hence what happens? Whatever the hot gases is there, right, that is come out. That means what? That expelled from the cylinder to the surrounding. Hence that what condition? Where the volume remains constant. That is nothing but what? Constant volume heat rejection. Okay, constant volume heat rejection. These are the four important processes are there in the diesel cycle. Here if you want to derive an equation for thermal efficiency of a diesel cycle, you require these four processes. Okay, now so I will now that four processes I can mark on the PV diagram as well as TS diagram. I can mark those on PV diagram and TS diagram. Okay, quick recall, dear students, what is 1 to 2? That is 1 to 2 is what? 1 to 2 is isentropic compression of the fluid. That means fluid is nothing but what? Air here. That is process we can call from point 1 to point 2. Okay, next 2 to 3 is what? Constant pressure heat addition. You are adding heat here at constant pressure. That means what? Heat addition at constant pressure. That means P2 is equal to P3. We can call it as a P. Okay, 2 to 3 is what? Constant heat addition process. The next 3 to 4. Next 3 to 4 is what? Adiabatic expansion. 3 to 4 is adiabatic expansion, or if it is happening suddenly we can call it as a isentropic expansion. Next 4 to 1. 4 to 1 what? Heat rejection. Again, how the heat is getting rejected here now? Heat is getting rejected at constant volume. Volume remains constant. But how the heat is added? Heat is added at constant pressure. Okay, this is what? PV diagram. So the same thing we can find it in the TS diagram also, but here we can see the variation of temperature versus entropy. 1 to 2 is what? Adiabatic compression. Then 1 to 2 is adiabatic compression. Then 2 to 3 is nothing but what? Heat addition. Again heat addition. 2 to 3 is heat addition at constant pressure. The next what? 3 to 4 is what? Adiabatic expansion. Adiabatic expansion. The pressure is going to drop from P3 to P4. The pressure is going to drop from P3 to P4, or we can say temperature is going to drop from T3 to T4. Next, 4 to 1, heat is getting rejected. Again what? At constant volume. So heat is getting rejected at constant volume. That heat rejection is represented as a QR. That too at process 4 to 1. Again what? Constant volume process. Hence the 4 to 1 is what? Constant volume. Cooling we can call, or heat rejection we can say, dear students. Now in the first process, now we will in detail we will study process 1 to 3, process 1 to 2, 2 to 3, 3 to 4, 4 to 1 in detail. Now what is our first process? First process is what? We can call it as a first process A. That is what? 1 to 2. That is nothing but what? Adiabatic compression. What happens in the adiabatic compression, dear students? That I already told now. So what happens in the adiabatic compression? Piston will be at TDC. It will start to move from TDC to BDC. Hence it is going to compress the air into the cylinder now. Hence what actually happens now? Now that means what? Piston moved from BDC to TDC. The piston moved from BDC to TDC. Hence what happens now? Volume decreased from V1 to V2, whereas temperature increased. Whereas temperature increased from T1 to T2, pressure increased from P1 to P2. This is what? First process. In the first process, what you have done? You compress the air. How you compress? You move piston from BDC to TDC, hence the air gets compressed, hence pressure, volume, temperature get changed from point 1 to point 2, we can say. This is what? Adiabatic compression process. That is important, dear students. Now next what you can see here now, the next process is what? Second process, that is what? 2 to 3, constant pressure heat addition. What is the constant pressure heat addition? That you can see here now, dear students. That also it told. When the piston is moved from BDC to TDC, right? Already compressed air will be there here now. Compressed air will be there. At that time, what we are doing? We are going to supply certain amount of fuel. That means what? We are going to inject small quantity of diesel into the cylinder. That means you are adding certain amount of heat. At what condition? We can see the pressure remains constant. That means what? P2 is equal to P3. At constant pressure, we are going to supply certain amount of heat. But when you supply the heat, right, then what happens now? The temperature increase from T2 to T3. That means you can see in the PV diagram also, dear students now. Okay, then what happens now? Temperature increased from T2 to T3, that we can see here now. Hence, the temperature increased from T2 to T3, as well as pressure also increased from P2 to P3. Okay, now you are telling, right, you have supplied certain amount of heat. Then how much amount of heat you have supplied? That can be calculated with help of an equation. You are telling, right now, dear students, with help, you are just a minute. You are telling right here now, you are adding certain amount of heat here now. Is it right? That means what? That means what? You are going to supply small amount of diesel. That means what? The amount of fuel. That is nothing. Mass of fuel is diesel, right? That how much you have supplied. That is nothing but what? In terms of kg. With the help of that, what we can do? We can calculate the heat supplied. How to calculate that heat supplied? That you can see here now, dear students. That heat supplied can be calculated at constant pressure using this equation. What is that? Qs is equal to m into Cp into T3 minus T2. What is Cp here now? The specific heat of air at constant pressure. Constant pressure, you have to remember. What is m now? M is nothing but what? Mass of fuel you have supplied. One thing, when, as I told, temperature increased from T3 to T4, that is what change in temperature. With the help of these all data, what I can do? I can calculate how much amount of heat is supplied to the cylinder, how much amount of heat is supplied to the air at constant pressure. So that we can call it as, that I will call it as a equation number 1. That I will call it as a equation number 1, dear students. Then next, this is what? Second process. Next, third process is process 3 to 4, adiabatic expansion. That means what? Once the heat is added, right, the piston will start to move from TDC to BDC. That we can see here now. Piston moved from TDC to BDC, hence expansion takes place. Dear students, you can see now heat you are added, right? That is very important here. That is very important, that you can see here now. Heat you added, that heat addition is represented as Qs is equal to what? M into Cp into delta T. That is nothing but what? T3 minus T2. That is what? Heat addition. Okay, that is fun. Because of that heat addition, the piston moved from TDC to BDC. That means what? Temperature varies from T3 to T4. T3 to T4. That is very important. That means a decrease. The volume also changes from V3 to V4. Once the piston moves from TDC to BDC means what? Volume is going to increase because the piston is getting expand because of the air. Okay, hence what happens now? But one condition we have to remember, dear students, while adiabatic expansion, there is no heat transfer at all. Hence it is called as adiabatic now. Hence Q equal to 0. The piston moved from TDC to BDC, volume increased, the temperature decreased, one thing, and also you can see there is no heat transfer at all. Hence I will mark it as Q equal to 0. But variation of temperature can be calculated with the help of an equation. That is what? With the help of a temperature variation versus volume. With the help of this standard equation, I can calculate them temperatures. Okay, how to calculate that? You can see now T3 by T4 is equal to V4 by V3 to the 4 of what? Gamma minus 1. This is what temperature ratio. That I will call it as equation number 2. Okay, during adiabatic expansion, the temperature variations is there, that I can calculate with the help of an equation. T3 by T4 is equal to V4 by V3 to the 4 of what? Gamma minus 1. That I will call it as equation number 2. Okay, next process 3 is over now. What is the last process? Last process is what? Constant volume heat rejection. Constant volume heat rejection. So now dear students, the heat is getting rejected from, right? Now piston will be at BDC only. We will open the exhaust valve, hence the hot gas will come out. When the hot gases is coming out, right, that hot gases carry certain amount of heat. That means what? Heat is getting rejected from system to the surrounding. That heat rejection is represented as a QR, that you can see here now. Then how to calculate that QR now? Again, at what condition that heat is getting rejected? At constant volume, dear students. The volume remains constant. At that constant volume, the heat is getting rejected. Then how much amount of heat is getting rejected? That can be calculated with the help of an equation. What is that? mCV. Now here I am taking CV. Why it's so? Specific heat at constant volume. That is nothing but what? T4 minus T1. The same thing I have written it here now. So heat rejection can be calculated with the help of an equation. That equation is nothing but QR is equal to M into CV T4 minus T1. Why it is T4 minus T1? That you can see here, dear students. Now high temperature. You can see TS diagram. Just a minute. Okay, heat addition takes place here, right? Heat addition is take place here, right? Just a minute. Heat addition, right? That heat addition QS how I can write now? QS is equal to M into, how we are guys supplying heat at constant pressure, right? M into CP into highest temperature is what here? T3 minus T2. This is what? Heat addition here now. The heat is getting rejected. How to calculate that heat rejection? QR is equal to, at what condition heat is getting rejected? At constant volume. M, instead of CP, what I have to do? I have to write CV, because the heat is getting rejected at constant volume. That is mCV into delta T. What is the highest temperature? T4. So therefore what I can do? T4 minus T1. So heat supplied and heat rejection. T4 minus T1. The same equation I have written here, dear students, that you can see here now. Okay, so QR is equal to mCV T4 minus T1. But what actually we are doing here in this derivation? We are trying to calculate the efficiency of the diesel cycle. So to calculate the efficiency of the diesel cycle, we know already generally. What is that efficiency of the diesel cycle? Generally we can take a efficiency. Efficiency is what? We know, right? Output to the input. Then what in output you are getting from the engine? That is work done, right? How much work it is going to do? That is work done. What is the input now? To get the work done, what we are doing now? You are supplying certain amount of heat actually. That supply amount heat is nothing but what? QS. Dear students, again according to first law of thermodynamics, what we are doing now? We are supplying certain amount of heat and we are going to get some amount of work actually. So therefore, efficiency is equal to what? Work done to the heat supplied. What is work done now? That also I told, right? Work done is equal to QS minus QR. QS minus QR. Okay, what is QS? And QS is heat supplied, QR the heat rejection. So therefore efficiency, how I can write now? So efficiency is equal to work done is nothing but what? QS minus QR divided by what? QS. The same thing I have written it, dear students. Now work done is what? QS minus QR, then divided by QS. Then QS is common here, I will take it out. So I will, here it is common, right? So therefore what I can do? Efficiency is equal to 1 minus QR divided by QS. The same thing I have written it 1 minus QR divided by QS. Dear students, already I told you what is QR. That QR value already we know. What is that? Okay, what is QR value? Now you got the efficiency, right? Efficiency of air is equal to 1 minus QR divided by QR. To calculate this efficiency, I should know the value of QR and QS. I should substitute. What is the value of QR? QR is equal to M into CV T4 minus T1. That I have substituted. But what is QS? QS is nothing but what? MCP. Here it is a constant volume process. Here it is a constant pressure process. Heat addition, constant pressure. Heat rejection, constant volume. That is MCP T3 minus T2. But M remains same because we have taken only 1 kg of air as a constant. Okay. So then what happens now? By seeing numerator and denominator, both M is common at both the denominator and numerator, just I will get cancelled. Then what I will do? What I will do? Efficiency of air is equal to 1 minus T4 minus T1 divided by T3 minus T2 into CV by CP. Okay. Dear students, one thing you have to remember here, one condition will come. So CP by CS, the specific heat ratio is nothing but what? Gamma. Gamma is nothing but what? It's the ratio of heat, specific heat of air at constant pressure to the constant volume. This is what specific heat ratio. This I can write if it's so. This I can modify and I can write if it is CV by CP. CP by CV is equal to gamma. So if it is CV by CP, then what will happen now? 1 by gamma. But here in this equation we can see it is CV by CP is there. What is the value of CV by CP? It is nothing but what? 1 by gamma. The same thing I am supplying here now. Same thing I am substituting here now. Efficiency of air is equal to 1 minus CV by CP is what? 1 by gamma. So 1 by gamma I written here. Then T4 I will keep it as it is. T4 minus T1 divided by T3 minus T4. That I will call it as equation number 4. So efficiency of the air standard cycle of diesel is 1 minus 1 by gamma to is gamma into T4 minus T1 divided by T3 minus T2. But when I can get the complete equation for thermal efficiency of diesel cycle, when I am going to substitute all the temperatures. So here if I want to calculate the efficiency of the efficiency of the diesel cycle, I should know the value of T4, T1, T3, T2. If not, I need to calculate these all values. I need to calculate T4, I need to calculate T3, I need to calculate T2, I need to calculate the T1. Once I know all the temperatures, then I can easily calculate the efficiency of the diesel cycle. How to do that? That we can see now, step by step now. This is what you can call it as equation number 4, whatever it is there, I will take it as equation number 5 now. So what I will do, if I want to calculate the efficiency of the diesel cycle, I should know the value of T2, T3, T4 and T1. And if you got the value of T2 and T3 and T4, right, that you have to express in terms of T1 for better simplification. How it is, that I will tell. Now what I will do, I will go with the first process. Okay, that is what? Adiabatic compression. When it is adiabatic compression, the temperature ratio versus volume, that I can express in terms of an equation. What is that? T2 by T1 is equal to V1 by V2 to the power of what? Gamma minus 1 we have. So now here, because I need, my intention is what now? My finding is what? I need to calculate T2, T3, T4. If once I calculate all these value, right, easily I can get the efficiency of the diesel cycle. So for that purpose, what I will do, I will try to calculate the temperatures individually. To calculate that, what I will do, I will go with the first process, that is adiabatic compression process, that to 1 to 2, where T2 by T1 is equal to V1 by V2 to the power of what? Gamma minus 1. So T2 by T1. What is V1 by V2? Already we know, RC. Some authors they will take small rc, some authors they will take capital RC. It is nothing but what? V1 by V2. So V1 by V2 is RC to the power of what? Gamma minus 1. Because we know RC is equal to V1 by V2. So therefore what I can do now? You do simplification. T2 by T1 is equal to RC to the power of gamma minus 1 is there. I will take this T1 at right side. Then what happens now? T2 is equal to T1 into RC to the power of what? Gamma minus 1. This is what? This is what? Temperature of air at point 2. At point 2. Okay. That I will call it as equation number 6. Similarly, what I will do, I will try to take the temperature ratio at expansion process. That is what? T3 to T4. Expansion process. Just a minute. You can see T3 to T4. So we know the equation. What is that? T3 by T4 is equal to V4 by V3 to the 4 of gamma minus 1. Dear students, you can see in the PV diagram. You can see it in the PV diagram. So what is the PV diagram? What is the condition here now? So you can see, draw a vertical line. So V1 is equal to V4. Why it's so? Because heat is getting rejected at constant volume. Hence V1 is equal to V4. The same thing I am substituting here now, that you can see here, dear students. Okay, so V4 is equal to V1. So say therefore T3 by T4. Okay, V4 by V1 is there, gamma minus 1. What is V4? V4 is nothing but what? V1. I will substitute V1. So dear students, you can see here now what I have done. So T3 by T4 is equal to V4 is nothing but what? V1 divided by what? V3 to the 4 of what? Gamma minus 1. But this I will write in this fashion. So V1 by V2 to the V2 by V3. So that same equation, V1 by V3. So if you cancel these two, right, you are going to get the same equation. But for my better simplification, what I have done, this same equation, it is there, right? What is that? V1 by V3 I can write in this fashion also. V1 by V2 multiplied with what? Again V2 by V3. If you get cancel these two, right, whatever you are getting, right, if you get cancel V2 by V2, you are going to get V1 by V3. This V1 by V3 I can write like this, or I can write like this. The same thing I have done it here, dear students. The same thing I have done it here now. So T3 by T4 is equal to V1 by V2 into V2 by V3 to the 4 of what? Gamma minus 1. But dear students, what is V1 by V2? We know already. RC is equal to V1 by V2. Fine. Then we know cutoff ratio one term will come. That is, cutoff ratio is nothing but what? It's the ratio of V3 by V2. But here it is V2 by V3 is there. So how I can write now? V2. So V2 by V3 I can write it here 1 by cutoff ratio. So the same value I am going to substitute here now. T3 by T4 is equal to what is V1 by V2? That is RC. I have written it here now. Then RC. Then gamma minus 1 powers will come this both side, right? RC to the 4 of what? Gamma minus 1 into V2 by V3 is nothing but what? 1 by rho. 1 by rho to the 4 of what? Again this value will come inside rho, that is 1 divided by rho to the 4 of gamma minus 1. So this is what T3 by T4. Now what I will do? I will try to calculate the value of what? T4 here now. So T4 is equal to what I can do now? Do simplification. This gamma into T3 into rho to the 4 of gamma minus 1 divided by RC to the 4 of what? Gamma minus 1. So therefore T4 equal to what we can get? T4 is equal to T3 into gamma minus T3 into rho to the 4 of gamma minus 1 divided by RC to the 4 of gamma minus 1. This is what we got, dear students. Now this is what? The value of T4. Now how many temperatures I calculated now? Because to get the efficiency of the diesel cycle, I should know all the temperatures now. T4 I have calculated. Okay, but one thing, you have calculated T4, but the T4 is not, it is in terms of T1. But you express all T4, T3 and T2 in terms of what? T1 only. But it is in terms of T3. But I will do simplification and I will try to explain this I will try to express this T4 in terms of T1 only. That I will explain. Okay. So now here you calculated T4. Then here you calculated, just a minute. Okay, you have calculated T4, fine. You have calculated T2, fine. But T2 is directly got it in terms of T1, no need to do simplification, that's fine. The next, any temperatures you have calculated? T4 and T2 is over. What about T3? T3 is calculated or not? Okay, T3 is not calculated, that we will calculate now. Okay, so now I will move towards next step, because T3 I don't know. I will try to calculate the value of what T3. Note that T4 has to be expressed in terms of T4, as I told dear students very clearly. Whatever the value you got it, right, T4 you got it in terms of what, T4 value you got it, but it is in terms of T3, but you should express the T4 in terms of T1. Why it is so? Why we need to express all the temperatures in T1? I will tell you, because of simplification, that I will tell. So one thing is that T3 we don't know. That T3 we can calculate at constant pressure process 2 to 3. There is one condition, V by T is equal to constant. That means what? V2 by T2 is equal to, this condition I am going to apply. V2 by T2 is equal to V3 by T3. I will do small modifications here now. T3 by T2, T3 by T2 is equal to V3 by V2. What is T3 here now? T3, you do simplification. T3 is equal to, you take this T2 into this side. So T2 into V3 by V2. What is V3 I told? So I told dear students, rho is equal to, cutoff ratio is equal to V3 by V2. So therefore, wherever V3 by V2 is the rate, I will mark it here rho actually. So T2 into rho. Why it's so? Because V3 by V2 is the cutoff ratio that we know already. Okay, fine. What is T2? But again, you T3 you got it in terms of T2. But what I have to do? I need to express all temperature in terms of T1 only. But to do that, what I can do? Somewhere I have calculated the value of T2. What is the value of T2? That you can see now. Somewhere else, yes, you got the value of T2. In equation number 6, you can see T2 you got it as T2 is equal to T1 RC to the 4 of gamma minus 1 is there. So it is already it is in terms of what? T1. The same thing I am going to put it here now. So T2 is equal to, what is the value of T2? T2 is equal to T1 RC to the 4 of gamma minus 1. So therefore T3 is equal to T1 RC to the 4 of gamma minus 1 into rho. That we can call it as a equation number 8. That we can call it as a equation number 8. T3 you got you calculated directly in terms of what? T1 itself. So you can call it as equation number 8. Okay. Now what is value of T4? Now in the previous step we can see here now T4 we have calculated, but there T3 we don't know, but now we calculated T3. Now we calculated the value of T3. That T3 value, what I will do? I will substitute in that equation. What equation? Now I will substitute equation number 7. Now what I will do now? I will substitute the value of T3 in equation number 7. Then, so what will happens now? This is equation number 8, right? Put that equation number 8 into equation number 7. Then what will happens? T4 is equal to T3 to the 4 of what? Gamma minus T3 into rho to the 4 of gamma minus 1 divided by RC to the 4 of gamma minus 1 is there. What is the value of T3? That you already calculated, right? That substitute here now. So therefore T4 is equal to T1 RC, the value of what? T3, T1 RC to the 4 of gamma minus 1 into rho into this value. The next T4 is equal to, do simplification here now. What happens now? Dear students, you can see RC, just a minute. Okay, here RC to the 4 of gamma minus 1 is there, RC to the 4 of gamma minus 1 is there, will be get cancelled. Then the remaining term is what? Remaining term T1, yes, T1 rho into rho to the 4 of gamma minus 1. Here rho is there, but the power of rho is 1, right? So what we can do, if there is nothing is there, to the 4 of rho is nothing but what? 1 will be there. So rho to the power of is 1 plus gamma minus 1. When it is both are same, right? Powers we can add. Powers of rho, this rho is 1. Powers of this rho is gamma minus 1. Both I am going to add it here now. That 1 plus gamma minus 1. Here dear students, you can see here now. This is plus 1 is there, it is minus 1 is there. Both will get cancelled. Then rho to the T1 to the 4 of what? Rho to the 4 is nothing but what? Gamma only. So therefore T4 is equal to T1 into rho to the 4 of gamma. That we can call it as a equation number 9. Now you got the temperature T4. That temperature T4 is expressed in terms of what? T1 itself. Okay. Now T4 you know, T3 you know, T2 you know, then T1 is already it is there in the T1 itself. Now you know all the temperature. Note when all temperature of cycles are known, efficiency can be easily calculated. How it is that we can see now. Now all this equation number 7, sorry, equation number 9, equation number 8, equation number 7, you substitute in main equation. What is the main equation? This is the equation, right? To calculate the efficiency, I required all temperatures. Now I know all the temperature in terms of T1 only. I will substitute here now. Now 1 minus 1 divided by gamma. What is T4? T4, T1 to the T1 into rho to the 4 of what? Gamma. That I have substituted. What is T1? I will, T1 is already there in terms of T1 only. I will keep it as it is. Divided by gamma is there. Okay, fine. Next, what is T3? T3 is T1 into RC to the power of what? Gamma minus 1. That I have substituted. Next, what is T2? T2 is what? What is the value of T2? T2 somewhere else you have calculated here. Okay, T2, it is there already. T2 is equal to T1 RC to the power of gamma minus 1. That I will substitute here now. If any common terms in this equation, I will take it outside. How it is now? 1 minus 1. Here T1, you can see T1 is common. I will take it outside. T1 into bracket rho to the power of gamma minus 1. Rho to the power of gamma minus 1. This is not raised to power minus 1. Na? It is only rho to the power gamma, then minus 1. Then here you can see, dear students, T1 RC to the power of gamma minus 1 is common at both sides. I will take it outside. But here one term is missed. Here it is a row actually. One row is missed. Okay. That is nothing but what? T3. T3 value somewhere else you can see now. This row is missed. Just we added row. So then I will take it outside. Then what happens? T1 rho C to the power of gamma minus 1. What is left out here now? Rho minus 1 actually. Rho minus 1, because I am taking T1 and RC to the power of gamma minus total outside, that rho minus 1. That is nothing but what? Efficiency of the diesel cycle, dear students. Now, so the final equation, this is nothing but what? Efficiency of the diesel cycle. If you want to common, you can make it T1 also you can remove, you can get cancelled. Okay, so efficiency of the air standard cycle is what? This is what the cycle PV diagram and TS diagram. The final equation for air standard cycle is efficiency of air standard cycle for diesel cycle is 1 minus 1 divided by gamma into T1 into bracket rho to the power of gamma minus 1 divided by T1 RC to the power of gamma minus 1 whole bracket rho minus 1. Whereas rho is a cutoff ratio, the gamma is the specific heat ratio. This is the thermal efficiency equation for diesel cycle. If you want to calculate the efficiency of the diesel cycle, I can use this equation. This is the one of the important derivation what we are having in our syllabus, dear students. Okay, dear students, I hope you understood this derivation well. If you have any doubts, you can comment and you can ask. Here I request you, please do subscribe my channel, okay, and support me. Okay, thank you. Please subscribe. Thank you.